This is Earth Science lecture number 12 on unconformities. In this lecture, we're going to look at what conformable strata are, and then we'll look at how various types of unconformities can develop and be identified, and those are called nonconformity, disconformity, and angular unconformities. First, before we look at what an unconformity is, we can consider the definition of a conformable strata. And conformable strata are basically layers of rock in which they've been deposited in such a fashion that there's been no interruptions in the deposition. So you've had a continuous sequence of deposition that's occurred in a particular area. So let's say you go to the Grand Canyon, you go down to the bottom of the canyon, and you have rocks that are exposed in these layers, which are shown as being red, and then we have green layers on top, and yellow layers on top of that, and brown, and so on. There's absolutely no interruption. There's basically no missing layers. There's no gaps in time. Your textbook talks about this, like if you were to imagine sedimentary layers that are laid down at a rate, let's say 10 centimeters per year. So 10 centimeters of rock would be forming in a sedimentary layer. And let's say that we can measure down and see how deep the layers go. Let's say that there's a total of 3 meters or 300 centimeters. We could figure out the ages of the rocks. If age is taken as the thickness of the layers divided by the rate, if we have 300 centimeters divided by the rate, which is 10 centimeters per year, we would have a sequence of layers which would tell us that we had about 30 years of geological history. Now there's a very big assumption with this, and that is that the rate of sedimentation is constant. And so we would have to run some experiments to see how sedimentation rates might vary in a particular place. And likewise, we would also have to be consider that there could also be interruptions in deposition of sediments. Sediments could have been deposited, but then they've eroded away, and in that case we would not have conformable strata. So conformable strata are basically layers of rock strata that show a complete geological history. Now, an unconformity is basically when you go through the rock strata or the rock layers that are exposed in a particular area, and you notice that there's a gap. There's a gap, so basically there's some layers which are missing. Now, there's two ways that an unconformity can develop. You could have basically an episode of non-deposition, and non-deposition would basically mean that we just don't have any sedimentary layers being laid down at that particular instant in time. The second way that an unconformity can develop is through erosion. Erosion is basically where the layers were deposited, but then they've subsequently been eroded away. They've been weathered down and transported away by some sort of agent of erosion, wind, water, glacial ice as well. So in class, we're going to examine an activity where we'll determine if there's an unconformity present in a sequence of layers. So we'll look at this some more when we get to our lecture. But let's go into some details now and look at the three types of unconformities. This image here is showing rock strata which are exposed in the Grand Canyon, and these red wavy lines are drawn in, and they are showing the different types of unconformities. So actually, if you were to go to the Grand Canyon, you would see all three types. The first type that we'll look at is called an angular unconformity. And an angular unconformity is probably the most obvious of the unconformities. What it looks like is basically a surface of erosion between two groups of sedimentary rocks. And the two groups of sedimentary rocks are shown here in this image. We have layers of sedimentary rocks below, which are numbered 1, 2, 3, 4, 5. And then we have layers on top of this black wavy line, 7, 8, and 9. And basically the two groups of sedimentary layers are going at two separate orientations. The layers below are at an angle with respect to the layers above. So this is called an angular unconformity. And in class, we're actually going to practice drawing an angular unconformity. I think that's a really good way to understand how they form. But if I could walk you through a step-by-step reenactment, We first have the flat layers, which are laid down, and probably they're laid down like where a river empties into the ocean. A river carries sediments down, and those sediments find their way to the ocean and form flat layers. And newer layers come and deposit on top of the older layers. So we have some nice flat layers that found their way out into the ocean. But these once flat layers become tilted by deformation, and so they become folded. A process which could lead to this folding might be something along the lines of mountain building. Like, let's say this region has a change in the plate tectonic setting, and we start to fold layers because mountains are being pushed up and where plates are pushing on each other. The folded layers, then the tectonic environment changes, and let's say the mountain building ends, and when things are sticking up in the atmosphere, they tend to be much more likely to erode. And so over the course of millions of years, those once folded layers have now been eroded flat. So if you go deep inside of the earth, you could still see the remnants of where the layers have been tilted. But above our surface, all of those layers have been eroded away. That's where the unconformity is. That's where the erosion has happened, and that's where the erosional surface has been formed. And then the last step, we have new flat layers deposited on top of these tilted layers below. And I have an animation here which also shows that. And so we first have flat sedimentary layers that are being deposited. The layers become folded and uplifted. They get eroded flat. And then new flat sedimentary layers are deposited on top. Now this animation shows everything happening at a very fast rate. And in real life, this would be something that would take millions and millions of years, probably hundreds of millions of years to form. So I'll go back to the PowerPoint. And in this image, you could actually see there's an unconformity that's present. I'll give you a second to see if you could make it out. These are real rock layers. And if you look at this picture, the layers below are almost going, if you see here, there's a rock hammer. Layers below are going almost in a vertical fashion. The layers above are going in a tilted direction in this orientation. So since the layers are going at two different orientations, the erosional surface between them, which if I could get a pen out here, let's see. The layers between them are going somewhere in this fashion, so the erosional surface between the layers would be something like this, and this would be where the unconformity would be present. And so the unconformity is this erosional surface. It's basically where you would have to detach the two groups of layers and insert the missing layers. Here's a few images showing examples of unconformities. Here we have layers that are, again, going in a very vertical fashion below, and then we have layers that are going in a more horizontal fashion above. And this is the actual location of those horizontal layers. Now, something to keep in mind with an angular unconformity, if the entire sequence of layers is tilted, so let's say we had these layers that have been completely rotated around, we would still have an angular unconformity between the two groups of layers. So the topmost layers do not have to be perfectly horizontal. They can also be tilted. It's just that the two groups of layers are at a different orientation with respect to each other. Now the next type of unconformity is referred to as a disconformity. A disconformity is an erosional surface that occurs between layers of sedimentary rocks. So it's very similar to an angular unconformity. But the difference between an angular unconformity and a disconformity is that the older layers, which are below, are going in the same orientation as the younger layers above. So if we have a sequence of layers here, these limestone layers, and above that we have, let's say, some sandstone layers, they're all going in exactly the same orientation. This type of unconformity really is the least obvious because you would really have to look and see where an erosional surface is present because you wouldn't see any obvious angles between the layers. And this would be noticed as a change in sedimentary environment. So you could have new sedimentary rock layers depositing down from a very different sedimentary environment from an older group of layers. So you could, let's say, have a glacial environment, and the glacial environment changes over into a river environment. You get a river environment that changes into a deep ocean environment. So that's what the disconformity shows you, is that there's been a group of sedimentary layers that have been deposited, but those layers have been subsequently eroded away. So let's walk through step by step how this type of unconformity will develop. So first we have sedimentary layers which are deposited. So I'll show a sequence of layers that are being laid down. And then the next step is that the sedimentary layers shown above are eroded. So if I have all the layers from the previous picture, but I erode the topmost layer. The next step would be a new sedimentary layer deposited on top of the entire sequence. And so now we have some new layers deposited on top. And the result is that this black wavy line basically represents where these layers, the brick layer, has been deposited, but subsequently it's been eroded. And so we have an erosional surface within the brick layer, which tells us that there's something missing, something has been eroded away. So when we're looking at the layers, we do not have a conformable sequence. We have a gap in time. And so here's an example of a disconformity. The disconformity is positioned here at the location of the hammer. So we have shale layers on the bottom covered by a conglomerate sequence of layers on the top. And so all these sedimentary layers are going in the same orientation, but there is a substantial gap in time, and there's an erosional surface that's present within the shale. Now, the big thing again to remember with the disconformity is that the layers above and below the disconformity are all going in the same orientation. They're not tilted with respect to each other. Although you could have a whole sequence of layers that become tilted, but notice there isn't any relative angle between the layers below and the layers above. So we would still have a disconformity between these two groups if the entire sequence were to be tilted. Now the last type of unconformity is called a nonconformity. And a nonconformity is a surface of erosion that will separate younger sedimentary layers. So we have sedimentary layers which are positioned on top, which are separated by an erosional surface, and below we have older igneous rocks or metamorphic rock layers. So different from a disconformity and an angular unconformity, a nonconformity actually has igneous or metamorphic rocks and sedimentary layers, where the other two types of unconformities we've just looked at only involve sedimentary layers. Now, in class we're going to go through an exercise practicing how to draw a nonconformity, but if I could show you a couple of images and an animation how this type of unconformity forms. Initially we have an intrusive igneous rock, or likewise this could be a metamorphic rock, that basically intrudes some layer. And we're just going to call it layer X, because the layer is going to, in the very next step, completely erode away. So whatever this intrusive igneous rock formed underneath, or whatever this metamorphic rock formed underneath, the layers above have been eroded away. And again, that's going to take hundreds of millions of years for it to be completely taken out of the picture. The next step, we have younger sedimentary layers which are laid down and deposited on top. And so the erosional surface that's present, which shows us where the intrusive igneous rock, or likewise the metamorphic rock layers, have been eroded down, is where we have the nonconformity. And I could show you an animation of this. And so in this animation, here I have an intrusive igneous rock, and so you could imagine this is a granite. This is something that's phaneritic texture, so very coarse. You could see that it had to form inside the earth, within earth layers. And then we have the layers that had formed underneath become eroded away. And following that, you have the erosional surface that has developed, and now newer, younger sedimentary rock layers are deposited on top. And so in class, we're going to do an activity practicing identifying the various types of unconformities, and so this is going to end our lecture tutorial.